For the fourth problem of the week, we want to find distinct integers a1 through a3 and b1 through b3, so none of them can be the same, otherwise that would be too easy. So that if you take x plus a1, x plus a2, x plus a3, square those and add them, you get the same thing as adding the squares of x plus b1, x plus b2, and x plus b3. Well, let me give a little bit of motivation for this. So there's a problem I saw, well, this point many years ago, where it asks you to express integers in the form, so you take plus or minus 1 squared, plus or minus 2 squared, plus or minus 3 squared, plus or minus 4 squared, and so on up to plus or minus, say, k squared. So you can take as many of the first however many squares you want, and then you put pluses and minuses in them, and it turns out that you can represent every integer in this way. It isn't unique, but it is possible. So for example, well, 5 is 1 squared, well, plus 1 squared plus 2 squared. Or for example, if you want, say, -2, you could do 1 squared plus 2 squared plus 3 squared minus 4 squared. So that's 1 squared plus 2 squared is 5, plus 3 squared is 14, and then you subtract 16. Okay, and there's a way to do this for every single integer. And the key is a proof by induction. You actually need 4 base cases. So you can write 1 as just 1 squared, 2 as, well, you negate what we had earlier. Three will be minus 1 squared plus 2 squared. And then 4 you can write as 1 squared minus 2 squared minus 3 squared plus 4 squared. So 1 squared plus 4 squared is 17, then you're subtracting 13, so that is 4. Okay, so those are the 4 base cases, and then the trick thereafter is to get from x to x plus 4, or say n to n plus 4, whichever you prefer. And the key is that for any x, not just an integer, but any complex x, you take x squared minus x plus 1 squared minus x plus 2 squared plus x plus 3 squared. Well, the x squareds, you're adding 2 and subtracting 2, so those go away. And then the linear terms, you have a minus 2x minus 4x plus 6x, so those go away. And you're left with just 3 squared minus 2 squared minus 1 squared, so you end up with just 4. So using this, once you have some number written as a sum of alternating squares, you can add 4 to that or subtract 4 using this trick. So now the problem of the week is to do essentially a similar thing, except you want to get 0 in the end. So there's no way to do this with just having 2 plus signs and 2 minus signs, but you can do it with 3 plus signs and 3 minus signs. So there are an infinite number of solutions, but the goal is just to find one. But if you're feeling so inclined, you could try to find an infinite number of them, or maybe even all of them.